When a coder sits down to start banging out code, the first thing to start crowding his cognitive load is whether his program will do what it should. Correctness, he says, is what makes my code good. It's the function that captures this coder's attention. Behaviors and inputs and outputs are mentioned, as if the one good that a coder can bring is to spin the right wheels on some Turing machine. And compiling and linking and running are great. We need to do these to put food on our plate. But the shocker that might leave you scratching your head is that actual code is less written than read. We spend more of our time in maintaining our stuff than we ever spend writing the simplest of cruft, which means that unless you've got something the matter, you'll try and learn just a few code style patterns. So coders and countrymen, lend me your ears as I teach you some lessons won hard through the years from that Beckian book about implementation and patterns that derail code suckification. A classical problem is how to name things. Oh, the anger and fights and dissension this brings, like off by one errors and cache expiration, a permanent answers beyond expectation. But a class should be named to describe its intent, not its implementation, though that's how we're bent. A superclass name should be pithy and short, a subclass's name a more detailed report. When you look at the name of a class, you should find the idea that hatched in the first coder's mind. Just what is the thing this class wanted to do, and what should you be thinking when first you call new? When you look at the name of a class, it's a sign, or you should find the idea that hatched in the first coder's mind. A good metaphor helps more than comments or training to inform other coders just what you're saying. The next thing we'll consider together is state, which wouldn't be bad if it wouldn't mutate. The functional people may think that they profit, but the objects we code will change state. We can't stop it. And it's not just concurrency where it can bite us, although many suffer from threadlock weightitis. The way that we organize pieces of state can make all the difference between good and great. Group similar state close together and see just what happens in time to your code quality. If you think of the reason your data is altered, your sense of the meaning will be less assaulted. The things that are changing together should be very close to each other, viewed all on one screen. The data whose purpose is common, same thing. If they all work together, keep them all in one scene. Remember the scopes an imperative language gives you to gather together your baggage. The method, the instance, the class scope are able to keep you from having too much on the table. The changing of state is a serious problem, and I think that we're starting to locate the bottom, but as long as assignment is part of our ken, we've got to try hard to keep data reined in. See, the coder who's reading this pile of junk is bounded in what he can think of at once. Don't make him scroll all up and down every file to find and recall every identifier. Now, the methods we write can get out of control when we make the one reading them scroll, 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 scroll. A method that's long and meandering is bad, but a method that's short and composed makes us glad. To compose a good method, just think of the scope of the things that it does, and with that, we can hope to keep all of its actions around the same level, or else its abstractions will leave you disheveled. A method composed by a coder who tries will read like a story with just one plot line. Each part of the story it tells is the same as the rest of the method, with all the same aim. To understand just what composing's about, think of a story of when you went out and first started the night by changing your clothes, then switching to tell me the distance you drove, and then up and describing the way you shift gears, and then a long, pointless tale about your rearview mirror, then changing your story to cover the dinner and how it was cooked and how long the sauce simmered, then skipping ahead to the movie you saw, but not telling me even one detail at all. Now, what would you think of this crazy approach? My mental disturbance would be hard to broach. It's the very same thing when we factor a method. Each one should stay small with its purpose embedded in a series of readable sub-method calls, and inside those methods go all their detals. When people are learning, they sometimes prefer first to know all the details and from them infer the concepts producing the detailed design. Either concept or detail can govern the mind. When composing your methods, keep this fact in mind, and please think of the coder who's struggling to find the whole shape of the picture zoomed all the way out, or the flipping of bits when that's what it's about. I think if you've listened a little to me, you might start to catch what I want you to see. It's good when we write code that passes our tests, but mere functionality isn't our best. It's the human who sits down to work with our code, our ideas we want to this one to be showed. So remember this saying, to the best that you're able, the reason you write code is to love your neighbor. Thank you.